Assalamu alaikum guys. Okay, we are back. In this lecture, we are going to do MCQ number 21 to 25, October, November 2009, variant 1, paper 1. Okay, guys, so the first question over here is very, very important. Many students find this very troublesome, so let's do this. Okay, the presence of 11 cis retinal. Okay, cis is written in this in the name. This suggests that there is a cis bond in there. This is the molecular formula that is given, and retinal Al means the in the end Al in the end suggests an aldehyde group which is present in here. And yes, this could be an aldehyde because there is only one oxygen atom in the molecular formula. In the cells in the eye is important for vision. Okay, the structure of retinal includes an aldehyde group, a cyclohexene ring, and a long aliphatic side chain in which carbon-carbon double bond exists between the carbon atoms numbered 11 and 12. Okay, 11 cis would mean that a double bond is present after the 11th carbon. Okay, if we try making out a structure according to the information they've given us, first of all, it's cis, right? So if we look at the answer options, the cis configuration is either answer option C or answer option A, because the hydrogen atoms are on the lower side in this case, so actually on the lower side of the double bonded carbon atoms, and the hydrogen atoms are in this case are also on the lower side of the hydrogen atoms of the carbon double bonded carbon atoms. So the same groups on the same side, same group on the same side. Now we have to check out the remaining information that's given in the question. It says a cyclohexene ring. So let's draw out a cyclohexene ring that I've drawn over here. Then they said that there are 20 carbon atoms. So let's try filling out the 20 carbon atoms. 6 carbon atoms have been taken care of. What about the remaining 14 carbon atoms? So just draw a long aliphatic side chain. And by the way, there in the end there is a place an aldehyde group as well, because aldehyde group comes in the end, and the aldehyde carbon atom. Okay, so these are 6, and then 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, and 20. This makes up a total of 20 carbon atoms. The aldehyde carbon is given carbon number 1. This is given the first number because the aldehyde groups have a higher preference. Now from in here, the let's look at the 11th carbon. So 1 2 3 4 5 6 7 8 9 10 11. Okay, this is the 11th carbon. After 11th carbon, this bond is in the cis configuration. Okay, this is what the question told us. And then they told us that there are now in if we look at option A and option C, they are asking us the number of carbon carbon double bonds, the total number of carbon carbon double bonds that are present in this structure. So two of them are given in the question. So two are already present, three more have to be placed, or four more have to be placed, because option A says five double bonds and option C says six double bonds. Okay, so now we have to try trial and error method and place six double bonds in this molecule, and then place five double bonds in this molecule, and see which one satisfies this equation, this molecular formula given over here. The total number of carbon atoms when I place them as five double bonds, this actually satisfies our formula, because if we now count down the number of hydrogen atoms in this formula, it turns out to be 28 hydrogen atoms. One oxygen atom is in there, and we have one, two, three, four, and five double bonds. So answer option A is correct. Okay, this was a very important MCQ, guys. Many of the students find it very, very challenging. Okay, so answer option A is correct. Then moving on to the next part, option number MCQ number 22. What is the least number of carbon atoms in non-cyclic alkane molecule that has a chiral center? Okay, the definition of chiral center is an atom, a carbon atom bonded to four different atoms or groups of atoms. So if this is our carbon atom, so let's try making out four different groups of atom, and this is a hydrocarbon because it's an alkane around it. Okay, so first we start off from by placing a hydrogen, then a methyl group, then two carbon atoms, and then three carbon atoms. So if we total them up, it makes up a seven carbon structure. Then moving on to the next MCQ, it says that the following diagram represents the structure of possible polymer. Okay, by which method would it be formed? Okay, this actually means that there are OH groups in there. Okay, and this is a polymer. Okay, so let's start checking out each of them. Okay, option A says that polymerize ethene followed by hydration. Okay, if we polymerize ethene, we'll get a polyethene molecule, which is a non-polar compound, and so it will not be hydrated. Okay, so answer option A cannot be correct. What about, because hydration is actually addition of water, this is a nucleophilic addition, electrophilic addition reaction, I should rather say, electrophilic addition of water. So electrophilic addition of water is not possible because this is a non-polar compound. What about polymerized ethane followed by oxidation with called acidified KMNO4? Okay, polymerization of ethene again will form uh, polyethene, and then polyethene, since it is non-polar, it is not an ethene molecule anymore, so it will not react with cold acidified KMNO4. So option B cannot be correct either. What about option C? Option C says the polymerized 1,2-dichloroethene molecule followed by hydrolysis. Okay, 1,2-dichloroethene. 1,2-dichloroethene would mean that we are actually trying to 1,2-dichloroethene would mean that a monomer like this. Okay, chloro, two chloro atoms and two hydrogen atoms, and this is your monomer. Okay, this monomer, when gets polymerized, it will form a polymer that contains chlorine atoms right over here on top of it. Okay, so each chlorine atom then can be replaced by a water molecule to form an OH, can be replaced by OH groups, okay, can be hydrolyzed to form your polymer that is given over here. A nucleophilic substitution reaction will occur, and so C is the correct option. It will give you the polymer right over here. Okay, now let's move on to the MCQ number 24. It says that sorbic acid is used as a food preservative because it kills fungi and molds. Okay, sorbic acid will react with hydrogen in presence of nickel catalyst. This is actually reduction or hydrogenation, and bromine in inorganic solvent. So bromine, addition of bromine, electrophilic addition of bromine. So how many moles of each is required? So this actually means that we are, as we know from theory, that 1 mole of bromine will go into one double bond. So over here and one double bond over here. So 2 mole of bromines are required. And what about hydrogen? Same, it goes for hydrogen. 1 mole of hydrogen in here and 1 mole of hydrogen in here. So 2 moles of hydrogens are also required. So 2 and 2 are the correct option. So let's look at the answer options that are given over here. Oh, just a moment. Okay. 2 and 2, option A is correct. Now let's move on to the next MCQ 25. Bromine reacts with ethene to form 1,2-dibromoethane. What is the correct description of the organic intermediate which is formed? This is electrophilic addition reaction, and in electrophilic addition reaction we get a carbocation, and carbocation has a positive charge. This means that it will be attracted to centers of negative charge. It will be attracted to negatively charged species. So this means this is actually an electrophile that we get. Okay, so that's it for this lecture. The link to the for the next lecture has been given in the description. In the next lecture, we are going to do MCQs number 26 to 30. Thank you so much.